You're now plugged in to the Delphi podcast.
Hey everyone, it's Tommy of Delphi Ventures. Welcome back to the podcast. Today I'm thrilled to bring on Logan, who is the founder of Zorp and Nockchain. We're investors, we're extremely excited. Logan, how you doing?
Doing great, Tommy. How are you today?
I'm excited to dive in. We have a really deep discussion, super ambitious product or project. Let's start off hot, man. Tell us a little bit about yourself.
Yeah, so my name's Logan Allen. I'm from Northeast Georgia, went to Georgia Tech, dropped out because I decided that Bitcoin was going to hyperinflate the dollar. Moved to San Francisco, started working at various startups. Found myself at Talon, of all places, working on Urbit with Curtis Yarvin, and did that for a few years. Then did a few kind of product studio type things for a minute. And eventually I found myself kind of back into crypto and working kind of adjacent to L2s. And then I got really interested in the idea of taking the Nock instruction set that Urbit invented and using it in a ZKVM context. Because I was looking at it and I'd been playing with it a lot, and I thought, it really seems like you would be able to get these binary trees that this Nock instruction set uses and make them really, really fast in a ZKVM. And went from there straight into some research with some math guys, and turned out we could do that. And then we said, well, what are we going to do with this crazy ZKVM? And we were thinking about all the things you can do with ZK, scalability, privacy, verification on-chain and proving off-chain, all those different types of things. And we said, you know what? We really just think we should do an L1 here. We just think that we've got something interesting with this really performant ZKVM and this different language ecosystem, and let's just give it a shot. And so we were thinking, what should we do? What kind of thing should we launch? And so we ended up saying, we've been really interested in Bitcoin and fair launches for this whole period, and we kind of felt a little, I don't know, not left out, but not as interested in a lot of the current market metas. And this was back in 2022, so all of the kind of high FDV
A generation ago.
Yeah, exactly. So long ago. All the high FDV proof of stake launches were going on around that time and were the hot thing. And we took a different path. And so we're doing with Nockchain, which is the L1 that we eventually ended up doing. Nockchain is a no pre-mine proof of work L1. And particularly, it's a ZK proof of work L1. So it's not doing the traditional hashing based proof of work. You actually make ZK proofs as the proof of work puzzle. So the miners are making proofs. And eventually we want those proofs to actually power the chain. So we wanted Nockchain.
Useful proof of work is definitely a differentiator. That is super unique. Logan, before we dive into ZK PoW, I want to just go back to that conversation. You're building this crazy tech, right? New VM, you're deep in the weeds, and you and your partners are discussing, let's launch new L1. I feel like there had to have been a lot of debates on where you could go, right?
Yep.
Like, what was the center of gravity to pull us into, hey, we want to launch our own blockchain. We know Bitcoin's huge. We know Ethereum, Solana there, but we know that we can compete and win. Like, how did you get to that point of confidence?
Yeah, no, that's a great question. So I was a Bitcoin maxi for a really long time. I really liked the whole proof of work aesthetic, how clean it was, and I really wanted Bitcoin to become programmable money. Well, in some ways it did, in some ways it didn't. And I've always been really attracted to minimal, clean abstractions that you can really grasp and understand without having to spend, 6 months mucking with it, or without having to kind of become some super expert in all the details of how it works. So simpler tech that is more understandable versus like really big, complicated gadgets, So that was something that had generally not been appealing to me about Ethereum, is that it just felt very big and complicated. Like they were just kind of shoving a bunch of research from here and there, really impressive research in the different cases, but shoving different research here and there without having a really cohesive underlying foundation. And of course, in part, I thought that that was not really anybody's fault, but just how it came about, because it had come about as one of the first chains and one of the most ambitious chains to, one of the first things to try Turing complete computation. And so it just inherited technical debt. And I think they did. I think they've done a really great job with where they started. But the tech has moved really far, and we've learned a lot about what you can do with the scaling blockchains and what types of cryptography are good for this, in the past 10 years. And so I was really starting from a point of liking the whole Bitcoin aesthetic, how it got there, and the minimalism of it, but wanting as a developer to be able to program my money. And ZK stood out to me as the way to do it, while basically getting all the things you would want. You get the trustlessness, you get the privacy, you get choices of how, as a developer, you want to do the execution. Do you want to do it on-chain, off-chain? It's kind of up to you. And one thing that I really couldn't imagine, in 2022 at least, is how you'd be able to make a really good developer experience for that. That wouldn't just lead to, yet another set of, $1 million audits. So I don't know how many developers are on the podcast versus kind of product or business people, but doing crypto dev is crazy. If you want to if you want to bolt on a data availability layer, or if you want to integrate with this Oracle price feed, whatever, anything you integrate with in an on-chain environment in your smart contracts is a potential massive security hole. And so every single integration has to be chosen carefully and then done carefully and then audited. And that's really expensive, right? Audits are not just, you check a box. I mean, it's an expensive process. You need real experts to go and look at that if you're going to put money in it. And so that was a process that I had kind of played with and had experienced. And I really wanted something simple. I wanted a much simpler computation layer where if I wanted to build something, I could just plug some proofs into it and it would just work. And I could just trust that that was going to work because the proof's verified. So that was kind of how we got started. We saw this problem of, there's these really interesting products with Bitcoin and Ethereum, but they have these different trade-offs they took. And it seems like if you were going to do it again today, you wouldn't necessarily have to take those trade-offs.
Yeah, no, it's a very clear pitch. It sounds to me like you really liked the simplicity and the security of Bitcoin, and you wanted to take that same look and feel of the safety and security to the next level, which is the programmability and what you can build on top of it. And it sounds like you weren't able to do that with Bitcoin itself, so you decided to work on your new thing.
Yeah, that's pretty much it. And then we saw this other kind of adjacent market mismatch, which is how we landed on the ZK Powell. So the ZK proof of work, which is the core consensus mechanism, we saw that there had been tons of venture money invested into making ZK proofs go fast, because there's a ton of interest in scaling blockchains and in privacy and in getting all of these awesome traits that ZK proofs theoretically provide. So we saw all this money going into making them fast, but we didn't see the work going into making them super easy to integrate with into existing workflows. And so the supply of ZK proofs was kind of starting to increase, but we didn't see profitable business models for all those companies focused on the hardware acceleration. And so we looked at kind of the proof market concept, which you see various projects attempting right now. And I personally found it really dissatisfying. This whole idea of we're going to have this special proof market, and that's going to be what gives all these hardware acceleration companies a business model. They're going to compete to make proofs in this little kind of auction thing. I looked at that and thought, well, you have this circular problem. You need developers to have a good enough experience that they actually want to use this stuff. And you need the proofs to be cheap enough to be supplied by companies. And you need the companies that are supplying the proofs to be able to make money doing that. All at the same time to be able to make this proof market concept work. And that seemed a little I mean, it's possible. I mean, but it's hard, right? That would be a really hard thing to build.
It is hard. I mean, this is a good starting point for the differentiation, right? If we want to work our way from the miners up to the users, now that we know the differentiation, right? Maybe let's
Sure,
start at ZK proof of work, right?
sure.
Bitcoin is, hashing, mining all around the world, globally secured. You have a different flavor of this. Let's dive into like what ZK PoW is, how it's different from Bitcoin, and what it enables.
Sure. So ZK PoW is really the core flavor of Nockchain. It's the secret sauce. It's the main thing that makes Nockchain what it is. We're really interested in building all these other things on top of it, but ZK PoW is where we started. We said ZK PoW is what Nockchain is going to be about. And so ZK PoW is a global permissionless competition to make the Nock ZK VM go as fast as possible.
That
And
is
to
so cool.
build and to build
That's
up
great, Brandon.
proving
Sorry.
capacity.
Sorry, please go.
Totally, yeah. So it's similar to what you see in some ways to some of the like experiments people are doing with distributed training now, because it's trying to leverage crypto incentives to build competition and leverage compute power and energy toward a purpose.
And the competition itself, like people throw around zero knowledge as a fantastic privacy tool, as a fantastic compression tool. Take all this data and post it, and it's easy to store. It's easy. Like, how conceptually are you explaining the fastest chain idea with ZK PoW? Because when I think of ZKs, I think of privacy and I think of compression. I don't really think of speed.
Sure. So what we're really focused on here is with making a minimal on-chain layer that can verify things as fast as possible so that developers can focus on building basically verifiable servers that can talk to each other and integrate with each other, post proofs to each other, and then check in on chain. So instead of doing API calls, you're privately proving things to each other and then checking those things in on chain.
That makes sense. And how are we linking the apps to ZK PoW? Like, because the miners are obviously working with the proofs from the apps themselves on top.
Let's start with the Dumbnet thing, and then we'll get to. So the initial version of Nockchain we call Dumbnet, just because kind of tongue in
I love
cheek,
that
like
name.
it's just the idea is like don't take it too seriously. This is our minimal first viable product. We're putting it out there. It's the minimal viable proof of work competition for ZK PoW. And so the first version, we're just trying to build up mining capacity. We're trying to build up proving capacity worldwide, proving Nock. And then we want to make ways to use that and to leverage that. And so in the beginning, miners are just proving these puzzles, and they're competing to prove Nock proofs the most, the fastest. And what we want to kind of build that into is start by just using the block reward to subsidize increased proving capacity. I spoke earlier about how the proof market concept kind of was a little funny to me because it seems hard to build up both sides of the market so that you get consistent developer demand for proofs while building reasonable and sustainable business models for proof providers. And so I think that a proof of work competition is the obvious approach to building a proof market. You start with a block subsidy, which makes sustainable demand, basically. It's the baseline demand is you get the block subsidy. But if people are willing to pay you more for those proofs than you would get for directing it toward the proof of work puzzle, right? Then you can get extra money. And so
Got it.
you don't even
Okay.
necessarily need crazy mechanisms to make that happen, right? You can just have people with an API that says I expect to get this much money for spending time on the proof of work puzzle. I have hardware that'll do any knock proof for you. If you'll pay me more to use that machine right now than I expect to get from doing the proof of work puzzle, I'll prove your thing instead. You just get it from the incentives.
Got it. So basically, in solving the chicken and the egg problem, you allow people into a competition to solve basic puzzles, not a real use case, not powering a real app from the get-go. You give them token incentives, and
Mm-hmm.
now you have all these miners on the network that are de facto ZK proving capacity that once they reach a certain level, then they could be leveraged for let's call it more productive use cases.
That's right. That's right.
And how do you like, as an app developer, like how do I go to the network and say, hey, I have some app I want to use. Maybe you can give me an example use case, and how
Mhm.
do they compete with the block reward? Are they paying in stable coins? Are they paying in your token? Like how do they say I'll give you more than that block reward?
Yeah, that's a great question. So one of the first upgrades that we intend to do to the chain is making it so that the chain verifies proofs that you post, and can use those proofs that you verify as spend conditions on coins. So we're in the UTXO model, so we have notes, not accounts. And so the idea is one of the very first upgrades is you can make it so that you have to show me a proof of some particular computation to spend this money. And so what that does is it unlocks all of the things that the intent model unlocks for other contexts. So if you've heard of Anoma or some of these other models where they're like, we really want to make it so that you can basically have order books that are just established on chain, that you can have kind of data markets on chain, or use on chain state as, say, like a queue for compute jobs even. All of that becomes possible in the intent model as soon as you have proofs able to be set as conditions to spend money. So for instance, I could say, I'll put this money right here, and if you can do this computation, say, prove that you did inference on this model, then you can spend the money, but you have to post the proof that you did that inference, so I can then use it.
Got it. Okay. It is a little hard to conceptually understand like how it would work within the network, right? Like
Mhm.
maybe we could just take a basic exchange example. Like I want to trade, let's say 100,000 USDC for some token, right? Like how do I
Sure.
gossip that intent out to or or not
Totally.
chain, sorry.
Yeah. So what you would do is you've got some coins, and you send those coins to a new address where the lock on spending the coins in that new address is that you have to satisfy an order book swap. So you show that you basically have the other party prove that they've swapped those coins, maybe even on another chain. You could do this with atomic swaps as an example. So you could lock the coins on Nockchain and say you can spend these as soon as you show that you've spent Ethereum to this address.
And where like do maybe I'm getting out of my technical depth here, but do app developers have to come and create the exchange logic, create the AMM, or are they able to do all of these things directly as proofs? I guess I'm getting a little confused as like what's possible as an intent first. Do I have to come to Notchain and build my app first?
That's a great question. So Notchain makes it very easy, and intents make it very easy to have little like micro apps where the app is really just a way to lock your coins paired with some watcher script that people can run to find coins that are locked in that way and interact with them. So a liquidity provider, for instance, is looking for swaps that they want to perform on chain, right? They're looking for coins that are locked, waiting to be swapped, and they're saying, do I want to do that swap or not? Is that economically profitable for me to do?
That is pretty cool. It feels like micro apps at scale through intents. Like, yeah, definitely not vibe coding, but
You could probably get to a vibe coding point with this type of thing, because it, instead of having these huge smart contracts that need to do all these integrations, you can have these little scripts, but that you can make composable with little like interlocking conditions.
that is pretty cool. I, I so I guess like zooming back down to
Mm.
the miners and the competition, everyone around crypto Twitter is focused on, throughput and TPS and latency.
Yep.
And we're all under this mental model of hardware and co-location and things like that. But the ZK component of Notchain, I think for me, kind of totally changes this dynamic, right?
Mhm.
Like what are you competing on as a miner to be the fastest to handle the most proofs? Is it just more hardware, or is it, yeah, how do you become the best miner?
So that's a great question. So as a miner, you definitely want more hardware, but the type of hardware that you want is rather different than the type of hardware you want in a hashing ASIC context. Okay, so you basically want to be really, really fast at doing polynomial math and doing specific types of algebraic hashes. And you want to be really fast at doing those in a compute pipeline. So it looks a lot more like high performance computing, HPC, like, supercomputer type things of, stringing together workloads, than it does like traditional mining where you don't have data inputs. And so what you really want is you want to make proofs as fast and efficient per watt as possible. And if you can do that, then you can basically have these job processors that'll either be processing proof of work jobs, or they'll be processing app developer jobs and just streaming them through. And one of the things that makes the note model or the UTXO model really compelling for this is that unlike what you have in the account model, where you have this one single state machine that's kind of that all the developers are kind of competing to use. In the UTXO model, each individual note has a dependency graph. So it says, I depend on this. And so you can do it in a massively parallel fashion.
That is really cool. Maybe I'd be curious to get your take on, if you're a Solana developer or an Ethereum developer, like why not just, everyone just says, oh, ZK it, like the ZK the L1. It is a little mystical in what it exactly means and the implementation
Sure.
of it. But I'm trying to just reason about the differences between you being a ZK native L1 versus others which are not, right? I'm trying to figure out conceptually like what that means for speed and latency and throughput.
Yeah. So every single, okay, so first off, the thing that you're getting from from a ZK native L1 is you're getting faster ZK verification of meaningful operations relating to blockchain state. That's what you're getting. Verification is already really fast, but the time between, oh, I want to do this computation, and oh, now I have a proof of it, and then I'm going to post it on chain and verify it. That's what we're trying to minimize. We're trying to make that into the smoothest, best pipeline possible. I want to do something, I get a proof, I verify it on chain. And so the chain just needs to be doing verification of proofs in massively parallel fashion, in a high throughput way. And then we want the ZK PoW competition to be building up high performance computers that are just streaming proofs through them as fast as possible. And then we've built Knockapp, which is a development framework for building with Knock, so that you can easily build off-chain verifiable services that can have a good DevX. We've even got a programming language that's very Swift-like. That's open source now. We're about to cut an alpha of it in the next few weeks. Right now, it's just a developer preview. But you can write regular looking code, and it's all type safe, and turn it into verifiable compute workloads that can be streamed through this whole thing. And so what we want to be building and taking the learnings from high performance computing, and then making the chain massively scalable by only having the chain verify proofs. And so that lets you have all of the heavy compute workloads happening off chain. And the app developers could even be doing them themselves if they wanted to.
I guess a dumb question for you, but I have Nockchain on one monitor, Solana on the other. I'm on Jupiter on Solana. I'm trying to process a transaction. I'm on Nockchain on the left. I'm trying to process a transaction. Does the added addition of requiring the proof slow down my experience versus using a Solana or using another chain? Because I don't get it. Yeah, like what's the difference in latency and speed if I have to wait to get a full blown ZK proof? Is it slower or faster or?
That's a great question. So this really gets into kind of one of the more interesting areas of emerging research in blockchains, which is the idea of being able to give you a pre-confirmation, right? Being able to give you a really fast pre-confirmation without having checked it in fully on chain. So what we're talking about when we're talking about you're going to prove it, then post it on chain, and the chain's just going to verify it. We're talking about having the fastest possible proof of work verified and secured and high throughput chain. So in order to get that really, really nice low latency experience, you really want pre-confirmations that are really fast, that your workload is going to be processed and that it is in a certain place in the queue. And so the way we view this is these are kind of separate issues of when is it fully settled versus when do you know it's going to happen in all likelihood.
I know I'm jumping around quite a bit, but I'm enjoying
No,
this.
it's all right. This is fun.
It's one of the things also that comes up a lot in infra L1 debates is just state size, state growth, things like that, right?
Mm.
The fact that you have your own miners is awesome because there's a physical representation of this around the world, people competing. How does the ZK component change the state growth of Nockchain? Like, are you going to
Yeah.
have petabytes of data per node, or does that change?
No, yeah, that's a great question. So this is something that actually was one of the more compelling reasons why we ended up building Nockchain. So we looked at kind of the state of light clients across the space and what it takes as a company to run your own full node. So there aren't really trustless light clients. Okay? Like those don't really exist. They're nice and as an idea, and you can get some guarantees that you're not being lied to about the chain without running a
Mhm.
full node. Um, but you can't get that many guarantees today without running your own chain. And so in practice, most users and developers use third-party RPC providers for Ethereum, for Solana, um, not quite as much for Bitcoin, but you can't do anything with Bitcoin. So there's kind of this like crazy split of you can't really do anything with Bitcoin, but developers and users can run their own nodes in practice. They really can do it. And then in Ethereum and Solana world, even development shops, like very technical developers that interact with the chain all day, they don't really run their own nodes. It's actually hard enough to do that. It's hard enough to keep track of that and to make it all work, and that in practice, it doesn't make sense for a company to do it themselves. They should go farm it out to someone else.
Mhm.
And this is partially because, it's a lot of work to be running these things in a trustless setting. But it's also partially because you actually are tracking a really computationally intense and complex process, and you need to keep it working. And so with the whole state growth question, we really want to be in a situation where, okay, so today all of the chains, Bitcoin, Ethereum, Solana, the way that they give you replicated global consensus across all of your different nodes and all your different people, the way they solve that problem is because every single node re-executes every single computation and transaction from scratch, and they have to have all the data made available to them to do that. It's a little scary. We did a lot of research into this, but Bitcoin doesn't have solved data availability, much less other chains. Like there's not a way to actually require and incentivize nodes to provide you historical data for Bitcoin currently. The default behavior is to do that, and so in practice you can get the data and everything, but there's not any like crypto economic incentive for nodes to be providing you data. You could have data withholding attacks. And of course, for Bitcoin, it's not as much data, and there's a lot of kind of like grassroots node providers and stuff. So it's less of a concern. But for Ethereum and Solana, which have way more transactions, way more data to process, where you need the historical transaction data in order to process and go through the chain state, that's actually rather intense as a requirement. So all of the current global consensus machines require you to be able to actually have every node publicly execute all of the chain state themselves, execute all the historical stuff themselves to get up to date. So every node executes every transaction. They all publicly replicate the transactions and the data. That's rather inefficient if you think about it, that they all have to execute everything. And so what we want to have happen is one person executes it and everybody else just verifies it. So instead of every single node having to replicate and execute every bit of data, we want one node to actually execute it and all the others to just verify it, because that's what ZK proofs let you do.
And then so like, I guess the centralization question for me would be, you mentioned like for the ZK PoW, you want these people to be, competing at this polynomial methods, I think you said in math, like, really hard deep tech stuff. Um, like, is there a centralization risk in the god tier math guy who figures out how to optimize his miners? Like, how I feel like we might run into similar issues maybe down the line. But on the other hand, if I could keep a compressed state of the whole chain on a flash drive or something as a dumb user, I would love to do that too. So maybe two different parties here.
Yeah. So just to wrap up the bit on the light clients, if you can prove it once and everyone else just verifies, not only is that more efficient because everyone else can be proving other stuff instead of having to re-execute stuff with the same compute power, but it also gives you the opportunity to make the data availability question easier by providing proofs of the historical state and then only needing to provide data availability on the current active chain state, which there's actually a lot of really, really interesting research, like Zoda as a recent example, around how to actually use a proof of work network to require data availability over certain parts of state. So anyway, we think that there's actually something really, really interesting there with solving data availability and removing the need for replicated execution that no one else has gotten basically in a production setting. But to back up to your question, I think the most likely scenario with ZK PoW is that we see it play out really similarly to the way Bitcoin has played out. I bet something like Bitmain, maybe even Bitmain itself, eventually comes in and starts making incredible ASICs for ZK compute, specialized towards the Nock ZKVM. And I think that what you see at that point is you see Nock as a standard of ZK compute, and the PCS, the polynomial commitment scheme, backing it as a standard for ZK compute. And I think you see commodification of proofs. And I think there's in those types of scenarios, there is a temporary centralization vector. But I think that the proof of work market incentives take care of it, and other providers replicate it. Other providers make competitive ASICs, and the actual economics of ASIC manufacturing and things like that end up actually making the network really, really strong.
It's interesting to think about. I spend a lot of time on the AI side thinking about GPUs and hardware and the differences. It sounds like from what you're saying, if blockchain is extremely valuable, there's clearly an incentive to either optimize your software or to build new hardware to compete, earn those block rewards, be
Yeah.
a faster proof provider.
Yeah.
Is there it is really cool to think about. What do you I'm trying to think through like do you have any idea of the speed or efficiency of the network on hardware today versus that custom hardware you're describing? Because I'm sure you have probably thoughts on designs for the hardware that could change.
Yeah. So the version that we're launching initially is basically a minimal viable miner reference client, which is meant to kick off the proof of work optimization competition. And so we are working to basically optimize internally. And I've told the Telegram, so I'm happy to say it here too. We don't currently have or utilize GPU or FPGA or ASIC hardware acceleration, but we've been working on optimizing this flow internally. And so at launch, everyone will be able to start competing to basically be the best at proving in this proof of work competition.
That is really cool. And like, what is the level of competitor here? Like, who is the person who could optimize their like? Could you be a normal Bitcoin miner, or do you have to be a miner with like a very dense knowledge of ZK, of math, etc.?
I think in the first probably 3 to 6 months, it'll be more weighted towards probably a lot of the existing companies that have already put work into ZK acceleration, and I think from there, it'll pretty quickly get further toward being able to be mined competitively by more normal miner profiles. But there's a lot of professional mining companies that have hardware acceleration expertise in-house that I am aware of, that are in our Telegram, that are talking to us and and I know are going to be competing on day one to get tokens. So I think honestly, even just in the 2 weeks or so since we put out the first initial open source version, I think we've really seen that the incentives of proof of work and having no pre-mine and doing a fair launch and letting people fairly compete here are compelling enough that people just come out of the woodwork to compete and participate in this. It's like a global performance competition.
It is. I mean, I'm just so excited for the resurgence of real world hardware, right? Like you're one of our
Mhm.
two portfolio companies that are doing useful proof of work, the other one for a totally different reason. And then you obviously have the entire AI buzz on just, distributed training and inference using hardware around the world. It really feels like we're getting back to proof of work to a useful GPU space, which is exciting.
Yeah. I think proof of work is the original DPIN.
You're not wrong. It is. So Logan, we talked a lot about the supply side, right? Like the
Yeah.
differences with ZK PoW, the hardware, the mining, the competition, the market. So let's talk a little bit about closing the loop for the consumer, right? Like
Hmm.
the look and feel of the applications, the security, the speed, like what can be built, what can't be built. Um,
Yeah.
Maybe if we could spend some time there, it'd be helpful.
Yeah, absolutely. So we've built a whole application framework called Knockapp. And it's all built in Rust, and we have a knock interpreter in Rust. We've got a way to easily make modular plug and play IO drivers. So you could say plug up an Ethereum RPC to your knock app. You could plug up, we already have stuff for obviously talking to Nockchain really easily and to Bitcoin really easily. And so you can basically build with this application framework any type of off-chain application. And one of our first things that we're really aiming to do is to make it very easy to integrate verifiable computation workloads into your Knock app, either that you run yourself or that you then submit to someone else to run, so that you can have compute posted on chain. And so we've really thought a lot about what does it look like to make it easy for developers both to build things that interact with Nockchain, but also to build in this new model of verifiable services. Verifiable services that are interacting both with the chain and with each other, and then getting their state checked in on chain.
Is there any part of the econ or block reward or any second order effect that you think could help, spur and grow that app community? Or are we too, is that like a couple months down the line and we're kind of focused on the mining right now?
So the very first, one of the reasons I've spent so much time on the mining is because the initial version of Nockchain is what we've called a Dumbnet. And so it really is just a basic Bitcoin transaction engine, Bitcoin-like transaction engine, hooked up to the ZK Powell competition. And so Nockchain itself is a Knockapp. So we view Knockapp as being as production ready as Nockchain is. So Nockchain is written in Rust and Hoon and is running Nock for all its internal logic. And so that's actually one of the things that we've done to make it easy for ourselves in the future to do upgrades to make proofs of what Nockchain does. Because you can run Nockchain in the Nock ZKVM.
That is pretty cool. Yeah, it's hard for me to mentally put it together sometimes, but it's interesting how easy it is. Um, what do you what do you think will be the first kind of killer apps on Octane? Just
That's a
curious,
good question.
what do you think?
Yeah, so the first big kind of app we're trying to do as a protocol upgrade is actually a Nockchain namespace.
Hmm.
And so I mentioned earlier how with intents, the general intent workflow is that you make these little micro apps that are these locks that you put on the coins. And then you often will have off-chain services that are looking for those locks that they want to interact with. If it's an order book, they're looking for swaps they might want to do. If it's a compute job service, doing say inference, you're looking for inference jobs to do. And so one of the things that would make that really easy for developers to use is a namespace. So if you knew where to look for those things. So if I'm looking for an inference job, I'm going to look under the inference namespace. If I'm looking for order book swaps, I'm going to look under the order book namespace. And one of the things that's nice about namespaces is that I just think people have an intrinsic desire to do name sniping. It's just fun. You see it with Ethereum, you see it, ENS, you see it with like Handshake, you see it, and there aren't that many of them, but anytime there is one, people have an intrinsic interest in getting their name or getting some fun thing that they think, that they want to speculate on. And so on the one hand, it actually serves as a useful way to index and organize different types of intents on the chain. But on the other hand, it's an easy upgrade we can do, and it provides something to do where you can lock up coins to buy name.
That is pretty cool. And it wouldn't just be a vanity address in terms of, Tommy.Nockchain. Like it would be for useful routing within the network.
Yeah, so it's a hierarchical namespace, just like a file system, where you can organize what kinds of intents and locks can be used within that part of the namespace. This one requires you to post a JPEG that satisfies these qualities, as an example.
That is pretty cool. Logan, I feel like there are I haven't had the time to think through it, but I feel like there are definitely some ways in which you guys will be involved with the open source AI movement, whether by choice or not, in a big way. Because, I mean, it sounds like you could do training and inference in a pretty confidential and quick way here. I mean, I know there's a lot to unpack there, but I'm just curious, like, if that's come across your desk for a use case on top of Notchain.
I actually talked to a decentralized training company last week about whether they could use the Notchain namespace and intent system to organize compute jobs on chain. So it's definitely something we've talked to people about. I think that there are use cases here. I definitely don't want to get out over my skis in terms of supporting this or that or whatever, but I definitely think that, frankly, one of the things I'm the most bullish about in all of crypto is the way that things like verifiable computation play with decentralized physical infrastructure.
Hmm.
So the framing I really like is we're entering into an age of computational commodities, where verifiable computation lets you package different computational services or even just an algorithm into a computational commodity offering that can be traded, that will end up at some particular price in relation to energy. And because different types of algorithms, well, they require different amounts of work to set up really, really good high performance computing pipelines for. Like ASIC hashing is a very easy high performance computing workload because it doesn't have any input data. It just sits there and spouts out ASICs or spouts out hashes. Versus distributed training, it's a lot more data intensive, and it's kind of circular. You need to do multiple passes and things like this. And so again, without trying to get out over my skis, I think that there's a really interesting world in which verifiable computation makes it easier to package various data and algorithms into basically, again, computational commodities that can be both traded but also that can be interacted with.
Yeah, that is. Yeah, I'm well beyond my technical understanding of decentralized training, but one of the biggest unsolved issues is just, um, you attract tons of capital to train a model, and the weights are open source, right?
Mhm.
So the end product is free. If somehow the model can be both secure and private, like on Nockchain and stored with the miners and continually updated, there could be a way where you get the best of both worlds, privacy and increases. But I guess we'll see who builds on Nockchain first.
Yeah, we'll see. There's a lot of different things. I think that internally at Zorp, we're going to be focused on a lot of the basic infrastructure pieces at the outset. So getting these upgrades to take the Dumbnet into giving it more capabilities to be able to actually verify proofs on chain, getting this hierarchical namespace for organizing intents. And I think the biggest thing on our menu after that is a simple HTLC, so hash time locked contract, for being able to do cross-chain atomic swaps.
Is there anything being built on top of Bitcoin that you think would pull in some of your target market? Because I know like that's a big, reason to do your own thing was to fix this, et cetera. But like any technologies there or projects you feel like, or just structurally and technically do you feel it's just not possible to have a thriving app ecosystem on top of Bitcoin?
Yeah, so I mean, obviously my early comments, around our survey of how possible it was to build things on Bitcoin were oriented around the market in 2022 and our in 2023 and our evaluation at that time. There's been a ton of interesting developments in the Bitcoin community since then around Opcat and Eric Wall and all these Bitcoin wizard guys trying to get ZK verify opcodes on Bitcoin. And I think that that's really interesting. I would love for Bitcoin to support that type of functionality. I think that there's a lot of kind of structural forces around the politics of the Bitcoin development that make it very difficult to push through those types of things. I wouldn't say it's never going to happen, but I think that those particular efforts like OpCat and OpCTV are the closest to what I would say are kind of similar things. Obviously, there's kind of L2s starting to pop up on Bitcoin, like Citria and things like this, and those are interesting, but the trust model is so different from Bitcoin that I think it actually attracts a different type of person.
Mhm. If you had to steal, or maybe not steal one, but if you had to think through like the biggest reason why blockchain might not be successful, right? The thing that keeps you up at night in terms of wanting to address, wanting to get past it, like what do you think that would be over the next 6 months? Like would it be, minor interest? Would it be the app developers? Like understanding like what's the biggest thing you're trying to address to clarify for folks?
Yeah, that makes sense. It's definitely building up the initial circular economy of Nockchain. So basically, giving people things to do with their coins once they've mined them, and being able to provide productive uses of capital and also just fun things to do.
Hmm.
Because a lot of the way that I think about early blockchains is it's basically a video game. And, our Telegram right now is a Call of Duty lobby. And the video game that we're going to play is we're going to be playing this game where you like run some funny commands in your command line, and then you try to compete with a bunch of people worldwide to see, how good you can do and how many points you get on the leaderboard. And so that's a fun game. People like that game, but you really want to make fun games that people can play after that. So name sniping is a fun game, right? There's a lot of prior art around I like that name and I'm going to do this with that name, things like that. But you want to be able to make more games, and they don't have to be, literally video games. But a lot of what we do on crypto today, whether it's pump.fun or the dev.fun, I forget the name of it, they're just making little games and getting people to participate in them, and then internet capital markets just do their thing. People like speculating. People, prediction markets. It's just a game. It's a really good game. You're betting on the news headlines, and so basically the way I think about this is we just need to make first the thing work. Second, link it to the existing capital markets, and then just make fun things that you can do that really uniquely leverage our capabilities. And if we can do that, then there will be a circular economy, and basically the market will take over.
I totally agree on the internet capital markets. I was up way too late making a tower defense game on Dev Fund. It is addicting. Um, but for blockchain in particular, like let's say I'm a miner and I don't want to play these games, right? I just I want to mine, I want to earn the token, and then my thought process becomes, okay, I have the token. Do I hold or sell?
Mhm.
When they go through the thought process of holding it or selling, that's key for the value of the
Sure.
ecosystem. Are they holding because it unlocks more or less um, capacity on the network later on as the miners get better? Like if I hold one token today, I could do some amount of capability in the network, but if the competition gets really nuts, I should unlock more value later, I think, or I think about it the wrong way.
Um, so the way I think about this, so Nockchain Nock token has a fixed supply of 2 to the 32 coins, and there's no pre-mine, and so miners are getting 100% of the coins. And so initially, um, the issuance schedule is steepest to basically attract a lot of the capital that's gone into basically ZK hardware acceleration. It's like, hey, here's something that you guys can do to compete with each other. And so after that point, The very first thing that you can do with the token as a commodity is you can just buy block space on Nockchain. Very simple, just like Bitcoin. But one of the areas we're the most interested in is in expanding the capabilities so that you're not just buying blockchain, you can be buying data availability. You can be buying, you can be buying and locking coins in a particular part of the namespace to speculate on a particular type of indexed locked script. So one kind of concept here is if you make an interesting script, an interesting type of locked script, and you buy some domain in the namespace that can only accept that type of locked script, then you're locking up coins there, and you can actually basically charge a fee on anyone to post things into that part of the namespace. And so I generally aim not to talk too speculatively about things that we haven't already built, but this is the direction we're going in. We're basically going in this direction of make a creator economy around these little like micro scripts for intents, and then use the fact that the namespace is intrinsically useful by indexing the computation and data that's posted on chain to make these like little mini markets around satisfying those intents in those namespaces, where the person that made that mini market can actually make money by doing so, by making that market in the first place.
Internet capital markets for devs.
Yeah, it's like, oh,
great.
I think that this particular style of AMM or this particular style of order book exchange or this particular type of price oracle, will take off. So I'm going to make a little script for it, and I'm going to make a namespace entry for it. And if you want to post things in that namespace entry and have watcher scripts that can satisfy those conditions and use them and all that stuff, then, pay me 1% or whatever it is.
So we're recording on May 16th. So maybe we're before or after, but how can people get involved with Dumbnet, with the mining competition? Like, where do they get started and what do they do?
That's a great question. So we're going to be launching next week. It's looking like we're going to be launching Wednesday, the 21st. We were originally planning May 19th, but you know how these things go.
Not the end of the world, 2 days. Yeah,
Yeah, no, I don't think it
that's
makes
a
any
small
difference.
delay for crypto.
Yeah, I don't think it makes any difference. Anyway, so it's looking like we're launching May 21, and you can get started by going to nockchain.org and signing up for the newsletter and hitting up that mining page, downloading the miner, and getting started with mining. The entire client is experimental, and we make no guarantees as to its behavior, but we encourage you to optimize the heck out of it and compete with all the miners globally.
Love it. I also love Nockchain's Twitter account. Whoever runs that needs a raise. Just the vibe there is great.
That's great, man. Yeah,
Yeah.
it's Justin Murphy, our creative director.
Oh, nice. Yeah,
I
props
run
to him.
the
It's
Zorp.
great.
I run the Zorp account, and he runs the Nockchain account.
Cool. Yeah, both good. Logan, just one closing question for you. I don't always get like such in the weeds technical founders on the show, right? Um, and it's such a journey that people do not see over the course of several years, right? They don't see the late nights, the headaches, the successes. What do you feel was like the biggest aha moment success over the last couple of years that the market probably will never see or hear about? I'm just curious.
Honestly, it's probably the stuff that we were doing at the very beginning so I was working with one researcher, Brian, and he's like a PhD mathematician. He got I don't know, he got kicked out of his like university because they were too woke or whatever. And so we were just working on this together for like 6 months straight, just in the very beginning in 2022 on the research side, on just trying to figure out how the heck we could make binary trees and represent them as polynomial equations. And eventually we figured out that you could basically organize a polynomial as a depth first search of a binary tree, and that if you did do that, that you could trivially compute as polynomials, concatenating two of these trees together into a new tree. And that was, you could do it by exponentiation. So you could exponentiate one of the polynomials and then just slap them together. And that was basically that moment was when we were like, wait a second, like we're cooking here. Like that's crazy that you can do that. You know what I mean?
I wish I knew the gravity of it, but I'm just not there technically. But I love that this is the example. It's exciting, right? It's just an awesome memory to have.
I think the second closest thing is what is it? Just when we made the knockapp framework work, basically.
That was more recent, or
That was last summer.
that is really cool. Logan, I feel like we had a great discussion. Did we not hit on anything that you want to let folks know about, or did we miss any like key segments?
No, this has been great, man. Thanks for the time.
I really appreciate it, Logan. It's cool. I feel like it's just so exciting to go from ZK PoW, useful proof of work, to the competition, to the apps that can be built on top. We're obviously extremely excited for you guys. So can't wait for this to get out.
Awesome. Thanks, Tommy.
Thank you.